for joining us. We're very happy to have Seecole, Assuta Ashdod, and Intersystems with us today. We have a lot to cover, so I'll keep it short and hand it over to Carl from Seecole, and we can begin.
Thank you. And pardon me today, my camera is acting up of all days, but I do promise that this is going to be very knowledgeable. It's not so much of a pitch, but we're just going to share with you a little bit of our journey when bridging AI with FHIR and some of the obstacles that we ran into and definitely some of the wins that we encountered. So hello, my name is Carl Osborne and I'm the founder of Seecole. We started off as an augmented reality medical device company. And with AI, we saw a goal to provide FHIR data at the bedside, at the point of care. And we're going to talk much more about that. I'm also here with my co-founder, Dr. Sherry Saltini. And before we begin, I really want to express my gratitude and thank Adi, Tani, Yafit, and the entire Israel FHIR community for this invitation. I've spent 16 years inside electronic health records integration work, and this talk is about what happens and specifically what breaks when you put a language model on top of FHIR. So this community has spent years solving a genuine hard problem, and it worked, right? We solved data access. What we did not solve is the clinician attention. FHIR made every resource reachable across the network. However, FHIR did not make any resource usable at the bedside. Clinicians still turn away from the patient, and then they bring their attention to a screen to go and find it. The bottleneck didn't disappear. It moved from a data layer to the interaction layer. I call this the interoperability paradox. The data is free, but the clinician's attention isn't. Roughly 40% of the clinician time goes into the record rather than the patient. Yes.
Carl, I don't know, I see a little like Teams message, which you might be able to hide, which is obscuring some of the text on the bottom. Oh, now I see nothing.
Does anyone see that?
Well, now we see nothing. I think you stopped sharing.
Okay, yeah, I just turned it off. Hold on. I'm gonna share again. Hang on one second. Entire screen. All right. What do you see now?
Yeah, so there's this little message.
Like right here?
Yeah. So you have a little hide button. Hide.
Oh, there we go.
Yeah. Right.
Gotcha. Okay. Thank you, Tani.
Sorry.
So no worries. So going back to what I was saying, again, roughly 40% of clinicians' time goes into the medical record rather than the patient. I don't know how it is in Israel, but certainly here in the States, this is a reported incident that occurs. It's been studied across many media outlets and clinical studies, and consistent with everything we observed in the field. Retrieving a single data point, which means just a simple lab test, means that clinicians click across multiple screens, and there are 0 hands-free paths in a standard electronic health record interface. Not a few, Epic, Oracle Health, any EHR, there is not a solution for the clinicians to interact with the electronic health record 100% hands-free, 0. So the data layer is solved, but as I mentioned before, the interaction layer is broken. I personally have 16 years experience in healthcare IT integration. I started off my career with Cerner, now called Oracle Health. I'm also Epic certified in inpatient clinical documentation, ambulatory, and with Beacon. I've also worked with other electronic health records, WellSky to mention, eClinicalWorks, and most recently, FHIR, Intersystems Iris. My focus has always been the integration layer, And the solution I've always tried to solve is a hands-free, some sort of hands-free solution to interact with clinical data. Sherry provides our clinical leadership. She owns the clinical validation and provider engagement. And as I mentioned before, Seecole is the company which stands for to see clinical data on lens. As you can see, we started off by augmented reality glasses where clinicians can call out clinical data and it appears in real time using FHIR APIs in the viewpoint of the clinician. Here in the States, we also offer the ability to document hands-free by saying simple video voice commands, and it goes in real time back into the medical record. We are an Intersystems Solutions partner and Ventures grant recipient, and we are currently active in a few clinical pilots. And how we got started, really, where we talk about our AI system, was that the question that was started, this was Sherry's question, not mine. And she asked, why does getting one number out of the medical record cost a clinician their attention? And so Mary was introduced, and Mary stands for our medical assistant and research system. The EHR still remains the system of record always. So we are not replacing the medical record. All we're doing is just finding a more hands-free solution of interacting with the medical record. The intelligence, our machine learning, our AI intelligence, and FHIR API layer. And then the point of care. This is where the clinician actually is. Voice-driven, hands-free retrieval directly in the clinician's field of view. It can be put on a mobile device, it can be done from a laptop, or it can be done from an augmented reality pair of glasses. It's grounded entirely and retrieved with FHIR resources, nothing else. And the most important thing, it's multilingual at the point of care interaction. Mary is a presentation and reasoning over FHIR. That's the whole claim. It sits on top of your current stack. It doesn't replace any part of it. So an augmentation of the EHR, not a replacement. The EHR remains the ultimate system of record. Read-only clinical reasoning, not writing back in retrieval mode. Strictly grounded in retrieved resources, not a general assistant that hallucinates or fills gaps. And it's not dependent on any single EHR vendor. Because it's light and because we have Intersystems Iris for Health, it can sit on top of any electronic health record. I want to be as direct as I can be about this because in our journey working with not only our Israeli friends, but other friends around the world, it's been the most common misreading of what we've built. Mary does not replace the electronic health record. In retrieval mode, it writes nothing back. The EHR remains the ultimate system of record. So what you're about to see I'll do a recorded walkthrough in English against a test patient. You'll see a couple of scenarios. I'm not going to run this live. However, we'll see where time goes, and I can definitely open it live and I can show you what we've built. And I'll come back to why I'm a little hesitant of doing this live. How this works is, once again, the query is spoken in a natural language. The clinician's hands never leave the patient. It's never away from the patient. And the clinical answer is derived only from retrieved evidence. So it only interprets FHIR API. Whatever information is in the chart, that's the only thing Mary is going to interpret. All right, so at this time, I'm going to share a video here. I'm going to share 2 videos. And let me know when you can see it. All right.
Here's a general treatment plan overview for the patient's conditions. 1. Hypertension and heart disease. Medications. Continue with amlodipine, lisinopril, nitro, and metoprolol.
Let's implement some interventions.
To proceed with implementing interventions, we can focus on specific aspects.
I'm trying to
Please
figure out
confirm
the
which
camera.
areas you would like to address first, such as medication adjustments, initiating or modifying prescriptions specific to hypertension.
Let's focus on the lifestyle modifications, particularly diet.
For dietary modifications, focusing on hypertension, diabetes, and obesity management might be beneficial. Here's a recommended plan. 1. Hypertension. Implement a low sodium diet. Aim for less than 1,500 milligrams of sodium.
Let's see. Let's order a consult for a nutritionist to see this patient.
To order a nutritionist consult for the patient, I'll create a service request. Here's what we'll include. Consult type, nutritionist. Purpose, dietary management for hypertension, diabetes, and obesity. Priority, routine. Would you like to
Yes, let's proceed with this order.
The order for a nutritionist consultation has been successfully placed for the patient. This will help in managing dietary needs related to hypertension, diabetes, and obesity. Let me know if there's anything more you need assistance with.
Yes, let's go ahead and draft the progress note based on everything that we've done.
Here's a concise summary for the progress note reflecting our recent activities. Progress note. Date, February 28, 2025. Patient overview. Current medications, lisinopril, amlodipine, tacrolimus.
See my medications here. I see the recent lab order that I placed. I see that the nutritionist consult order is here. So this is awesome. And now this is probably the only time I feel now I should be going into the medical record in this patient's chart. Now that's what I like to add or modify and finalize the note. But that's the cool thing, because using smart FHIR. Let's go ahead and finalize the note. Thank you. And so a lot to unpack there before I get into the second video. And then, you know what, as a treat, I'll do a live demonstration. Why not? You saw a lot of things happening in that short video. You saw me really in real time by natural language processing, interacting with FHIR data in real time. That test patient is actually on the EPIC sandbox, which means that when I'm interacting with Mary, within EPIC, I'm documenting and I'm also retrieving information in real time. In the demo that you saw that I placed a consult order, the workflow is that when I do that by voice command, it's when I log into hyperspace, it's there for me in a draft mode. So again, we're not replacing the electronic health record. We're just augmenting it, a way that it's hands-free, a way that the clinician doesn't necessarily have to spend too much time in hyperspace. They can use their voice and interact with the medical record. I'm going to show you one more video, but the last thing I want to say, the interface, right? For those folks who were watching it, you notice that it was in a horizontal sort of interface. That's because in that specific interface, it was built for augmented reality devices. Here is one for a tablet and a phone device, and you'll see that the UI looks a little different. Based on lab test, should I change medication or dosing? Oh, and this is on augmented reality as well.
Carl, is the video playing?
Yeah, so you're not seeing it?
We saw it, but I don't think we heard it too much.
Okay, so I can
now.
Was anyone else able to hear that?
No.
Okay.
No.
All right, no worries. So I can briefly explain and then I'll go into a live demo. So once again, in this version, that is the version that is set for the augmented reality glasses. All I did was ask about the patient's medications, and based on her diagnosis, should I change the dose? And the thing about with Mary, it's never going to hallucinate. It's never going to interpret or to pull things from the internet. It's only going to interpret, and it just gave me advice based on certain criteria within her chart, certain things that I should be made aware of. But let me get into a live demonstration. And let me pull up Mary. All right. So I need to attach Mary to our patient database. All righty. So the first thing with Mary is that just like with clinicians at the bedside, right? I don't know really in Israel, but in the States, you have to identify your patient by name and date of birth. So even in the design of Mary, we do not sway against how the clinical workflow in the inpatient or even ambulatory takes place. So from here, I'm going to say Dwight Hill, August 24th, 1984. And now what it's going to do, it's going to find that record. And when it does, then that's when I accept it, just like you would in the bedside. Now, let's say that we don't know anything about this patient, right? And let's say I'm doing a physician handoff. The first thing I'm going to do is get some sort of background, what's going on with this patient. And by a simple query, I'm going to pull all of that FHIR data. So I'm going to say, please provide me with a clinical summary on this patient. And now what it's going to do, it's going to pull using FHIR, it's going to pull observation, condition, it's going to pull diagnosis, it's going to pull the encounter history, all visit. It's going to give me a complete summary on this patient. Please provide the clinical summary.
The patient's active conditions include type 2 diabetes mellitus without complications and social isolation. Resolved conditions include not in labor force, acute viral pharyngitis, disease caused by severe acute respiratory syndrome coronavirus 2, fever, cough, suspected disease caused by severe acute respiratory coronavirus 2, dental filling lost, gingivitis, full-time employment, medication review due, reports of violence in the environment, stress, part-time employment, and educated to high school level.
So it now just gave me a little bit of overview about this patient. Now I really want folks to really focus on the information that it pulled, right? Notice that this patient doesn't have cancer, okay? So now I'm going to ask a question about the patient's cancer, okay? Mary, when was the onset of cancer for this patient?
Based on the patient's record, there is no cancer condition listed.
So again, it cannot hallucinate, because the way that we built the architecture, I'm getting to that next, is that it only interprets the clinical data, the FHIR. That's it. That's all Mary is doing. Now, the advice that it's given, we've plugged that into a clinical evidence-based database managed by the US government. So if I wanted to know how to do a treatment or how to proceed with anything, it's only going to pull that clinical evidence-based information, and that's how it provides guidance to the clinician hands-free. We did say it was multilingual. One of the obstacles that we worked with our Israeli counterparts was that we understand that some of the providers, some of the physicians may flip from Hebrew to Russian to English. And so that was an obstacle, and I'll talk about that in a little bit later. But as you can see, a clinician, whether you're a nurse or a physician, and you speak in a different tongue other than English, you can interpret by your natural language FHIR request and get the same thing from Mary. So let's go ahead and I'm going to show you some more advanced features from Mary. But let's go ahead and pull the observation, and I'm going to pull some labs, okay? Mary, can you give me Dwight's latest lab results? And again, all it's doing, pulling FHIR APIs, it's looking into it.
Mary, Dwight's latest lab results are.
Right.
Play the
Based on Dwight's lab results and Dwight's diagnosis, plus some of the ongoing conditions, what are some treatment plans, or what are some risk factors, rather, that I can see in Dwight? That's a lot, right, folks? For those folks who are clinicians, that question alone will take a plethora of screens. You have to analyze the labs, and you got to see the trends. Then you got to compare that to see any differential diagnosis, right? That question alone can take a lot of time within the medical record. And in under a minute, you're going to see how Mary pulls that and then provides that information.
Based on Dwight's diagnosis of type 2 diabetes mellitus and his lab results, here are some risk factors and potential treatment considerations. Risk factors: type 2 diabetes mellitus. This is a significant risk factor for cardiovascular disease, kidney disease, nerve damage, eye problems, and increased susceptibility to infections. Elevated triglycerides.
For his type 2 diabetes, is Dwight on any medications currently? Again, talking in my natural language, interacting with FHIR data.
Dwight is currently dosages of 350 milligrams and 500 milligrams.
All right. So again, for our Israeli friends, we have the capability of writing prescriptions hands-free, placing consult orders. We offer this to our clients in the States. As of right now, with our partner here in Israel, they just wanted to pull information or retrieve the information hands-free. But we certainly have the capability of writing consult and prescriptions. So I talked heavily about pulling the data. I'm going to give you a treat, and let's go ahead and order a consult, and you'll see how we can do that hands-free. So, Mary, I'm really concerned about Dwight's diabetes management. Let's go ahead and order a consult for a nutritionist.
Certainly order a consult for a nutritionist for Dwight. Just to confirm, would you like me to add a service request for a nutritionist consult for Dwight?
So the key word here for those folks who are familiar with FHIR APIs, notice it's this service request, right? And as I mentioned before, in Epic or Oracle Health or any electronic health record, once I confirm that by voice, it's going to put it in a draft mode back into the electronic health record. All right, so I hope that shows you just a little bit of what Mary's capability, what we've been working very hard to accomplish, and some of the safety mechanisms, right? When I talked about cancer or things of that sort for a patient that doesn't even have it in the chart, what we've worked so hard to accomplish. Notice what Mary's answers were doing. It reports only what the record supports. So how in the world did you all do that, right? What is the secret sauce, so to speak? And we're certainly not going to share the real secret sauce, but how can you kind of attempt something similar? And so the user interaction layer, you saw that with the video. We have the augmented reality. I'm on my desktop, so I can certainly use a web-based application or a native app. And then you saw me interact with Mary using natural language for reasoning and decision support. And then it's the EHR data integration layer, right? So that's Iris for Health, and that's the secret sauce, and I'll talk a little bit about that. And the FHIR API, which is a FHIR API connector. So we never plug directly into the EHR, okay? The secret sauce is Intersystems Iris for Health, because it's brokering out to Epic and other EHRs and other clinical databases. The model never talks to an EHR directly. I just really want to make mention of that, because that's something that Sherry and I have encountered with piloting here in the States, is that a lot of people get nervous when you plug in AI, right, to their electronic health records, so much clinical data, so much at risk. But thanks to Iris for Health and the FHIR APIs form a strict interaction boundary, and everything the model sees has already crossed it. So every request is inspectable at the boundary. Every response, right, is attributable to resources that came back through it. So what we're doing, we're swapping. The source system is an integration change and not a model change. To give you more of a visual on this is that, you know, Mary is not just another chat box, right? You know, yeah, you can go into Claude, or you can go into ChatGPT and ask a plethora of questions. You can upload documents, certainly. But the thing that, again, we do is that we only interact with what's in the chart. We don't reach out to the internet. We're not pulling from other models. All Mary is doing is interpreting what is currently in the chart. And how that is that it starts with a spoken query, right? That you saw me doing. Clinicians ask in natural language or in their native tongue, hands-free, okay? The intent resolution is parsed to a clinical intent and a patient context, not keyword matching, right? We need to know what is being asked about whom. Notice that I mentioned Dwight. Dwight, what about, I'm so concerned for Dwight. What is Dwight's labs? And so I'm not just asking kind of queries out there, and Mary's not trying to grab keywords. It's understanding the context. The scoped FHIR request, obviously it's the crucial step. This is where most of our engineering effort went. We request only the specific resources this question needs, right? So I was asking, hey, what about the labs? So it tied into that specific FHIR API, and it presented that. It didn't give me anything else. It didn't give me anything irrelevant to the question. And we validate the request before it's dispatched. We do not fetch the patient. We only fetch what the question requires, as you saw. Per query, not per patient. Validated before dispatch, the model doesn't get to send whatever it composed. This is what keeps an answer traceable to specific resources. Then we have the broken layer. Intersystems Iris for Health integrates and caches across source systems. Grounded response, the answer is strictly constrained to the bundle that came back. So this step, and then the most important one is really step 5, is the safety argument, right? And it depends entirely on step 3. The answer cannot exceed the evidence that came back. And the evidence that came back is only what the question actually needed, as you saw. Dwight doesn't have cancer, so why are we even talking about it? And as you can see, let's move on. Let's talk about Dwight's risk factors, and it presented precisely what I wanted based on what was in the chart. Per query retrieval, not per patient. That's a design decision, not a performance optimization, right? Never bulk load. We don't push a patient's record into the context window. Beyond the mechanical problem, a model that has seen everything can relate anything, right? As you saw, right? Wow, I'm really concerned, do we know Dwight has type 2 diabetes, other safety risk factors? So, okay, is he on any medications, right? So again, it's only just gonna pull the clinical answer and what the clinician needs at the bedside. Retrieval sources, the values. The model only explains them. When I asked about, can you give me a clinical summary? This was a perfect example of that. This is the division of labor that makes the whole thing defensible. The numbers come from FHIR. The language comes from the model, but the model never originates a value. Absent data is reported as absent. never estimated. So there is, Dwight doesn't have cancer. So why am I even talking about that, right? If the bundle doesn't contain it, Mary says it doesn't have it. A general assistant fills gaps. A clinical tool refuses to. Refusal is a success state in our system, not a failure. So a reality check, right? I showed off a little bit of what Mary, but to get to this step, yeah, we have a reality check. And we're going to talk about how our Israeli friends helped us to get to this point. So the context window overload, right? So you can imagine if I ask about a clinical summary for a patient that's been admitted for quite a few days, that can get very convoluted. So a broad retrieval blew out the context window. So patient records are large and FHIR bundles are verbose. So we pull the record. Is not a viable strategy. And I know that's what a lot of people do when they interact with FHIR. Let's just pull what we got. The fix was a dynamic per query retrieval. So this was when I asked, yeah, give me, the risk factors on the patient. Notice it broke it down, right, to each of the diagnosis or based on each of the risk factors in a 2-sentence. And it gave me a summary on each of those risk factors. The principle we took from it, retrieval scope is a clinical decision, not a memory optimization. What you choose to fetch determine what the model can conclude. Model-generated FHIR is wrong. We let the model compose FHIR request. And what we got was malformed parameters, missing required elements, and worst of all, silently empty results that looked like negative findings. Mary didn't say anything. The fix was a real-time validation layer between the model and the endpoint, correcting before dispatching. So, perfect example. What used to happen is, oh, hey, does Dwight have cancer? And it would just circle and nothing. What we added was that validation record. So now Mary can easily say, well, guess what? That's not in the chart, right? So the clinician's never lost in the interaction with Mary. So we treat model-generated FHIR as untrusted input. Imagine that. That's the way that we did it. Even though we're pulling from FHIR, untrusted input, because we need to validate it at the boundary, exactly as you'll validate anything arriving from outside your system. The third thing that we ran into was sparse error semantics. So thin documentation and minimal error messaging from vendor endpoints like Epic or Oracle Health. Failures came back without enough information to act on programmatically on anything. So our fix, our own error feedback loop, plus structured workarounds for failure modes we could characterize. So we budget for the endpoint silence, not just its response. So I can just feel the vibe here, and I'm willing to guess that there are a number of people even in this webinar that have hit at least one of these three. And if you probably hit a fourth that's not here, we genuinely would love to hear the discussion today. We understand that what we are asking or our solution is a little bit out of the box. It's a little future forward, so to speak. And so our path to trust, our implementation support. So our Israel HDP profiles, the conformance target being mapped rather than blindly inserted. Okay, so we work with those to kind of see what the clinical workflow is, and then how can we conform Mary to support your clinical workflow. Thanks to our friends here on the webinar, a sandbox first, and you'll hear a little bit about that later, a resource and profile validation before any clinical evaluation. Of course, right? Any developer knows that, right? We want to put it in a safe sandbox environment to see, wow, can Mary do things? What are some risk factors? And what are some things that we can kind of enhance? And that goes into number 3, clinical discovery. So we're building with clinicians, always building with clinicians, not presenting a demo at them. You know, clinicians, you all are at the bedside. What are some enhancements that we can make with Mary? One of the best feedbacks that we gotten was providers, physicians would like to flip between English, Hebrew, Russian, right there. I don't want to have to click. I want to just be able to do that in one setting. And that was very valuable to us. And the last thing here, our approach is retrieval before action. So read only until retrieval earns trust. Order placement, write back, are future capabilities, as I mentioned for Israel, but not today's headline. On the first point, I'll be straightforward. Several people in this room know the Israeli profile landscape very better than what Sherry and I do. If our mapping approach is wrong, this discussion at the end is the most useful that we would really appreciate if this approach hits the mark. And as I mentioned before, again, some of the feedback that we got was when people hear multilingual, they think translation. Certainly we did. In a clinical setting, the harder problem isn't translation. It's the three languages arrive at once, and all of them have to land on the same code, right? So English, Russian, Hebrew, all resolving to one normal FHIR concept. So the challenge was code switching, right? Clinicians move from Hebrew, English, and Russian inside a single utterance, sometimes inside a single clause. So there's no select language moment, and we're working hard to kind of to work on that. For our Russian friends, right, the Cyrillic translations, medication names that are in Russian, right, are translate inconsistently. And so we're working on that. And the reason why we take this seriously, because a near miss on a drug name isn't a near miss, it's a clinical failure, right? So we want to make sure when that physician, that nurse utters that medication in Russian that we're hitting the mark. And then our terminology binding. A clinical concept must resolve to the exact same code regardless of which language it arrived in. Otherwise, the record fragments by language. And to be clear about why this matters commercially here in the Israeli market, as well as clinically, supporting Russian is a workforce working condition in this market, not just a nice request. And so as I go back to that last slide, this is where we work with clinicians who tell us, some of the real important gaps, and we work hard to get that resolved. And so before questions, I know towards the end of this, I want to be precise about what works today and what doesn't, okay? Because I'd rather you hear it from me than find it in the Q&A section. So what's functional? Yes, of course, Mary, Russian speech to text and Russian clinical reasoning, that does work. What we're working on, again, is just that medication drug name that we found. Another thing is that we in-clinic pilot FHIR grounded retrieval in English and also in Hebrew and also in many other languages. However, one of the things that we observed was the way that you all pronounce names, right? And we're trying to find the right API so that when we open a chart by saying a patient's name, it can open the name properly based upon the dialect. And we're finding some struggles in that. We're working on that. As I mentioned before, under validation is the Russian drug name recognition, and also, as I mentioned, the Hebrew transcription accuracy, which was opening up or saying a name in Hebrew. What's out of scope today for the Israeli market is writing back. This was a request that we heard. It was just a little bit too advanced. Though we do have it in our arsenal, it's just not in scope today. So environment-specific validation is a required step, not a caveat. It's why you saw I started off with a recording earlier, right? But then I showed the live session. And it's why I'm not going to quote you any Hebrew accuracy number I can't defend today. So let me ask you something instead. Where we are now with our Hebrew market, and especially the Hebrew speech to text being benchmarked, we're looking to see what can we benchmark it towards. And if there is an answer in this community, that's worth more to us than anything, because we really want to nail getting Mary integrated into your clinical workspace. And so 3 things I'll leave you with. 1, FHIR solved access, not attention. The interaction layer is still ours to build, and it's a standards problem as much as it is a user experience problem. 2, treat model-generated FHIR as untrusted input. Trust me on this. Validate at the boundary. And 3, multilingual clinical AI is a terminology problem before it's a speech problem. Once again, I'd like to thank the FHIR Israel community for having us. My details are on the screen, and looking forward to some really good discussions. Thank you very much.
Thank you, Carl. Would you like to have questions now, or shall we move to Yochai and have everything at the end?
I don't mind moving towards the end and then answering questions.
Okay, so thank you very much. Yochai, would you like to share your presentation? We can't hear you. You're muted.
It is better now?
Yeah, that's great.
So thank you, Carl. I'll share my presentation. Okay, can you see my screen? Okay, it's going to be, I think it's going to be a much shorter presentation, and I hope it will be as fascinating as Carl's presentation. I'm going to talk about the medical sandbox, the Asuta Ashdod medical sandbox. We were working also with Seecole on this platform, and I'm going to present what it is. My name is Yochai Edlitz. I'm the CTO in the Asuta Ashdod Innovation. We also have here Dr. Gil Levy, who is managing the Asuta Ashdod Innovation. And what we built in the last few years was the Asuta Ashdod Medical Sandbox. We wanted to enable partners to develop, validate clinical AI inside a live hospital. So we'll give you a short overview of this. So what was the challenge? The challenge is why healthcare innovation needs a secure AI research platform. So we all know that for healthcare innovation, we need restricted data access, we need patient privacy, we need long validations. We don't need, but there are long validation cycles, infrastructure complexity. We need to secure compute, GPU, AI tooling. All of them are costly to build. We have some regulatory requirements like cloud committee and health thinking committee, ethic compliance, and we also need AI governance for medical data, which is, in other areas are not that strict. So our solution was to build the Asuta Ashdod Medical Sandbox. It was built also with the support of the Israeli Innovation Authority. And it's one secure hospital environment to develop, validate, and deploy clinical AI without data ever leaving the research room. We provide longitudinal, multi-center, international data collaboration capabilities. So our platform. On one hand, we have the customer, which are the healthcare companies, innovators, which might be pharma, medtech, AI startup, universities, national health organizations. They can connect to our medical sandbox, where we provide to them de-identified data with governed access, multi-center and international research, and full audit trail on AWS, with all the security in place and all the privacy that is required by regulations, the identification, anonymization, etc. We also have clinical experts that can help the groups that are working on this in this sandbox. We are working together with our clinicians, with our hospital clinicians. The research data, which is longitudinal, multi-center, and international. And when I say multi-center, it might be using federated learning that we can connect. Federated learning is where we take several centers, enabling data at each of the sandboxes, of the separate sandboxes. And we have a central place where we can train a model. Where we have the model, then we set the model weights to each one of the sandboxes to be trained there, and then we return only the models without the data ever leaving the sandbox itself. So it's a secured way for training models in several centers together. We have our AI infrastructures. We have allocated GPUs if are required. Not everyone requires GPUs. Sometimes, they are quite costly, so not everybody needs them. We have connections to LLMs, which is quite unique because we are working on AWS, so we can connect to Bedrock on AWS, which contain, LLMs like OpenAI, like ChatGPT, Claude, which are the known ones, but also like Mistral or also open code LLMs. And we also enabled the connection to GCP, Google Cloud Platform, where they have also Gemini. So if you're working on Gemini, we can enable this communication and the work with Gemini. Everything, as I said, is secured, and we can enable also clinical validation from retrospective studies to prospective pilots. So we're actually transforming the hospital data into validated clinical innovation. So what is the clinical data that you currently have? We have more than 500,000 patients. We have more than 10 million laboratory tests and more than 500,000 imaging studies. We have longitudinal EMRs, diagnosis, procedures, medications, clinical notes, multi-year follow-ups, and we can have more according to if there is a requirement. We can connect also other types of data. It's a near real-time EMR copy that is synchronized to our EMR, to the Chameleon, to our BI, and we have one source of truth like that. We have also hospital BI integration, as I said, and FHIR interoperability. We also have working with Iris from Intersystems on a FHIR server. Okay, so as I said, all of the things that I already discussed are kind of differentiators. Is secured enterprise LLM access, as I said, local AI models as well, GPU infrastructure. So we took care of of having these GPUs available to the researchers. We have research environment, which is called RES, which is research environment on AWS that enables us to manage several researchers groups working in parallel, and we have isolated containers workspaces. We can deploy Jupyter, Dockers, Python, R, Excel, whatever the researchers need. And we have also secure data exchange capabilities using vault-controlled upload and download systems. So we are whitening everything that is going into the system, and we also monitor everything that our clients want to download from the environment. Okay, so a bit about like high-level architecture. On one side, we have the hospital EMR, hospital BI. We said near real-time sync, be identified. We have data sources. Some of them are already available. Some of them. So the hospital EMR and the hospital BI are available near real time and be identified. And we also have other data sources that we can connect according to requirement, which is imaging, labs, pathology, hospital admin, surgical video, services and surveys, CRM, clinical pharmacy, human resource, and more. In the middle, we have the actual sandbox that is sitting on top of AWS. We have the research database on a FHIR server. We can also work not with FHIR. Okay, if there is a requirement working directly with the data and not in FHIR format, we can also do this. AI development environment, secure LLM gateways, local LLMs, GPU cluster, and we can also dedicate clinical team for validation of the data or the trial. What else? I think I talked about this, the external LLMs and the federated learning. That's it, I think, regarding the architecture. So what is our partnership journey from innovation to clinical validation? First, we define the project. We work with our partners, with the clients. What is the clinical question? What is the sub-cohort or the cohorts that they need? We check how much of this cohort do we have. We check that this is something that is compatible to what the customer actually requires. We see that we have the required ethics approval, if it's Helsinki, if it's the cloud committee, that everything is approved. Once we defined it and approved it, we started to develop and validate the environment. We deploy what the customer requires on the sandbox workspace. We see that we have the resources for the AI development. We perform all the connections. We do some data validation to see that everything is available. And the next stage is to go for production. So we assign the clinical team for review if required. It's not always required. We start prospective pilot or started research the data, and at the end we have the conclusions, and we can close the project. So it's one governed pathway from clinical question to deployed validated AI. All this, we are trying to do this journey quite fast, okay, to accelerate. This was one of the main incentives here to try to make this fast. Usually defining the project takes between 2 months to 3 months. Developing and validation may take also between around 2 months. Actually, it might also be much shorter, from 1 month to 3 months, depending on the complexity and the special requirements. And the production, as long as the research is alive. That's it. So the outcome and deliverables of this is clinically validated AI models, real-world evidence and publications, regulatory submission support, multi-center international reach, faster time to clinical evidence, lower infrastructure cost, and deployment in a live hospital. Here I have a small, actually it's quite an old demo, but a demo of how we work on one of the projects in the environment. We're working with Jupyter Notebook using FHIR, connecting to Iris. I don't know how many here are working actual hands-on on using Jupyter Notebook, but we can see that we connect to the server, and then we can start having the interrogation, the data science, the fun part of the work as I see it. That's it. I think if you have any questions, I'll be happy to answer.
Thank you, Yochai. I think, Tani, we can begin with you now, and then we'll have all the questions together at the end. Okay.
Great. So you see my screen?
Yeah.
Excellent. So first I want to thank you, Adi, for organizing this webinar. I'll thank the distinguished presenters before me, Carl and Yochai, both from our dear partners from Seecole and from Assuta Ashdod. Actually, I'll mention maybe also Matrix Medika, and are presenting today. We are sort of behind the scenes of part of the sandbox at Assuta Ashdod. So what I want to do today in a few minutes is sort of maybe continue a little bit what I spoke about last webinar. And I'll start actually with the same slide I started last time. I'll just go through it a bit faster. So we're talking about sort of 3 steps where we at Intersystems are seeing where we're going with the FHIR server. So we started with the foundation, with this, let's call it the plumbing. By the way, Adi, you prefer me speaking in English or in Hebrew?
Whatever, like, doesn't really, it's fine with me if you keep it in English, but whatever you prefer.
אוקיי.
Do you think
לא, סתם,
switching to Hebrew will be easier for the next part of the questions, maybe?
Okay, so I'll do Hebrew, and I'll apologize for Carl. So sorry, Carl. Or anybody else here who's more English speaker. טוב, אז התחלנו לדבר בהתחלה על השרברבות, על האינסטלציה של ה-FHIR, שזה בערך המצב שרובנו עדיין נמצאים בו, אבל אם אנחנו מסתכלים קדימה וחלקנו כבר נמצאים שם, וזה הצד היותר סמנטי, בשביל להבין בכלל מה שהולך פה. ואגב, אני חושב שקארל בהחלט התייחס לזה, חלק מהדברים שהוא דיבר עליהם, FHIR פתר חלק מהדברים, אבל לכשלעצמו לא פותר הכל. אז פה אנחנו נמצאים כבר בצד הסמנטי, ואיפה שאנחנו משקיעים היום זה בעתיד לא כל כך רחוק, אבל העתיד שכולנו שואפים אליו, שכרגע אנחנו כבר מדברים עליו, זה הנושא של יותר הקוגניטיבי, או להיות מסוגל to reason with it, להיות מסוגל להתמודד עם הדאטה הזה יחד עם AI, עם כלים של AI. ופה אנחנו משקיעים כרגע, וזה מה שאני רוצה לדבר עליו כרגע. אז פעם שעברה, מי שזוכר, מי שלא יש הקלטה, הצגנו ודיברנו קצת על יכולות של vector search בתוך שרת ה-FHIR שאנחנו מכניסים, ולהיות מסוגלים לעשות חיפושים סמנטיים על דאטה שהוא unstructured data בתוך ה-resources של ה-FHIR שלנו, אבל מה שאני רוצה להתמקד עליו היום הוא אזור קצת אחר, הוא אזור של לחבר tools ו-MCP server ו-agents לתוך שרת ה-FHIR. זה הנושא שאני רוצה רגע להתמקד עליו. והרעיון פה הוא, ושוב אני מדגיש, הדגשתי גם פעם שעברה, אני אדגיש גם עכשיו, מה שאני אראה תכף ואני מספר עליו כרגע, לא קיים במוצר היום עדיין. כן? זה משהו שאנחנו עובדים עליו, אז מי שירצה לרוץ, להתחיל להשתמש בזה, נשמח לדבר איתו, אבל זה לא איזה משהו שיכול להוריד ולהתחיל להריץ ככה out of the box. אז מה שאנחנו כבר יש לנו היום מוצג פה בשקף, משהו שאנחנו קוראים לו AI Hub, זה כבר יכולת שקיימת היום וזמינה במה שאנחנו קוראים Early Access Program, וזה אומר שאייריס יכול לבוא כבר עם MCP Server, ועם יכולת להגדיר tools משלכם ולחבר agents אליהם. אז זה כבר יכולת שקיימת היום ב-Early Access Program. אבל מה שהולך להיות, מה שאנחנו בונים בעצם עכשיו, זה לא רק שאתם תוכלו לחבר ל-MCP Server עם אייריס ולבנות tools משלכם, אלא שבתוך אייריס כבר יהיו טולים מובנים וגם ספציפיים ל-FHIR. זה בעצם הרעיון שאנחנו מדברים עליו כרגע. זאת אומרת שאייריס יבוא כבר עם MCP Server ועם טולים שחושפים את היכולות של FHIR. אז אתם היום רגילים להשתמש ב-FHIR ולשלוח REST API, כן? אבל הרעיון פה שתוכלו לחבר טול, שבצורך העניין איזשהו LLM שמצפה להפעיל איזשהו טול, איזשהו agent שיכול להפעיל איזשהו טול, ששרת האייריס שלכם, שרת ה-FHIR Server שלכם יוכל לחשוף החוצה. וזה בעצם יהיה משהו שיהיה מובנה ו-out of the box. אפילו לא, אני אומר, כבר היום אתם יכולים עם ה-AI App לבנות משלכם, אבל הרעיון הוא שזה כבר יעבור חלק מהאייריס, חלק כבר מובנה, כולל כל הצד של ה-security והחיבור, ל-LLM שצריכו לדבר עליו, וכל ההרשאות וכל הדברים האלה, שאין לנו זמן כרגע להיכנס אליהם. אבל זה הרעיון, זה הקונספט שתוכלו לבנות בעצם מנגנון או פתרון של agents שידברו ישירות עם שרת ה-FHIR שלכם דרך הטולס שיחשפו באייריס. ואני אראה לכם עכשיו דמו קצר של הדבר הזה. שוב, רק בשביל לסבר את האוזן, זה לא משהו שממש מוכן, אבל רק שיהיה לכם משהו יותר ככה לחוש אותו בעיניים על מה שאני מדבר. אז אבל בנינו איזשהו שרת FHIR, יש בו מידעים שונים, ומה שגם בנינו זה agents. אז אתם רואים פה למשל 6 agents שקיימים, אחד שמתמחה בנושא של triage, אחד בנושא של diagnostic, אחד בסג'גן וכו'. ואני בעזרת ה-agents האלה, שכל אחד יש לו את המומחיות שלו שיודע לעשות דברים מסוימים, אני יכול לבנות בעצם מה שנקרא workflows, אני בונה מעין תסריטים שאני יכול להפעיל אותם, והתסריטים האלה יפעילו agents שונים, אז למשל אחד שיתמקד ב-lab results review, ואחד נלך ב-hypertension, וכל אחד יש flow, שמשתמש באג'נטס האלה שהולכים ולעשות כל מיני דברים. אז אנחנו למשל, יש לנו כל מיני מידעים בתוך שרת ה-FHIR, ריסוסים, אז אתם רואים פה למשל observations כאלה ואחרים, וכל מיני איבנטים שקורים, כל הדברים האלה קיימים בתוך שרת ה-FHIR, וה-agents יוכלו לעשות interactions עם הדברים האלה. אז נראה לכם לדוגמה איך זה יכול להיראות, דבר כזה. אז אני נניח רוצה להפעיל עכשיו את ה-workflow של ה-Lab Results Review, שמפעיל כרגע שני agents, Diagnostic Agent ו-Scheduling Agent. זה מה שאנחנו רוצים לעשות. Diagnostic Agent evaluates results and triggers scheduling for abnormal findings. זה נשמע שאנחנו מזהים אותו כפחות טוב בתוצאות, אנחנו רוצים כבר לעשות schedule לדבר הזה. זה ה-workflow שאנחנו רוצים להפעיל אותו. וכמובן שיעניין אותנו פה קצת, בתור אנשים שמתעסקים מ-FHIR, מאחורי הקלעים. אז קודם כל, אתם רואים פה, זה ה-Diagnostic Agent, שהוא מפעיל טולים. עכשיו שוב, הטולים האלה אמרנו יהיו ממש חלק מהאיריס, אז נניח להיות מסוגל להסתכל על observation, אז הוא מסתכל על ריסורס של observation, אתם רואים פה למשל את הריסורסים של ה-FHIR שאנחנו מתעסקים איתם, patient, observation, diagnostic report, ואלה הטולים שבעצם מאפשרים לנו לגשת לריסורסים האלה. אז זה למשל האג'נס הראשון של ה-diagnostic, הוא מצא דברים מסוימים, הוא מעביר את זה הלאה ל-scheduling agent, אז הוא שוב פעם מתעסק עם עוד ריסורסים, עם patient, עם appointment, עם schedule, עם practitioner וכו', בשביל להיות מסוגל גם ממש לעשות דברים. כמובן שיש פה טולים אגב שלא קשורים ל-FHIR, הוא רוצה לשלוח SMS, אז הוא שולח SMS, אז יש פה בעצם שילוב בין טולים FHIR'ים לטולים כלליים שאנחנו רוצים להתעסק איתם. אז זה דוגמה למשל ל-workflow אחד שיכול לנצל את הטולס האלה בתוך שרת ה-FHIR. במקרה הזה היה לנו שני agents ב-workflow הזה. ב-workflow הבא שאנחנו נרצה להסתכל, יש לנו כבר 4 agents, וגם פה אותו עיקרון, יש לנו בעיקרון אחד שעושה triage, אז גם פה הוא עושה read ל-patient, זה הטול שהוא עושה, ומתעסק פה עם ריסורסים של patient ו-condition ועוד ועוד ועוד, ובמקרה הזה הוא יפעיל סך הכל 4 agents בשביל לעשות עוד דברים, אז הוא עושה triage, הוא עושה diagnostic, ושוב יש לנו את אותו scheduling agent שפגשנו קודם, והוא עושה את כל התהליך הזה, כל ה-workflow הזה, אפילו billing agent וכו'. זה הרעיון, זה הקונספט שאליו אנחנו הולכים, בונים MCP server, טולים מובנים לתורת ה-FHIR שנמצאים כבר בפנים. ועכשיו אני רוצה להראות לכם עוד משהו קטן, גם זה אני אקשר את זה למפגש הקודם. מי שזוכר, ואני לא אבחן אתכם, לפחות לא כרגע, אולי אם תשאלו אותי שאלות, המחיר יהיה שאני אבחן כל מי שישאל אותי, קחו את זה בחשבון. אז בכל מקרה, הייתה לנו תחרות, כן? תחרות עם פרסים וכולי, סביב AI agents ו-FHIR. פעם שרה הראיתי לכם פתרון אחד, היום אני אראה לכם פתרון נוסף. אגב, הפתרון הזה כרגע רץ אצלי, כל הפתרונות הם open source, לכל אחד יש GitHub repository שאתם יכולים להוריד ולשחק איתם, וכולם עובדים ישירות מול IRIS4Health, שגם אתם יכולים לנסות לשחק איתו, כל אחד עם דוקר קונטיינר של עצמו, אתם יכולים להוריד ולשחק. בכל מקרה, מה שיש לנו פה, אגב זה הפתרון שניצח, היה מקום ראשון, יש לנו ממש דמו שלם שמראה לנו הרבה מאוד agents, אין לנו זמן עכשיו להדגים לכם את כל ה-agents, אבל רק שוב שתקבלו איזשהו טעם, איזשהו רעיון. אז יש לנו למשל הראשון שמסתכל על imaging, אז למשל נעשה results follow-up, יזכיר לנו אגב מה שראינו קודם, אז יש לנו פה איזושהי גברת, מיס את'ל ברנט, יכול להיות שיהודי, אני לא יודע, כן, זה שם קצת יהודי. בכל מקרה, אז היא, למשל יש לנו פה איזושהי ממוגרפיה, שהיא הייתה צריכה לעשות ולא עשתה. אז יש לנו פה ריסורסים שאנחנו עלינו עליהם והסתכלנו עליהם וקראנו אותם. ה-AI כבר הכין לנו איזשהו draft message לגברת, שוב זה לא נשלח, אבל מכינים לנו את זה בשביל לשלוח לה, ויש לנו אפילו פה order request, כן, diagnostic program with possibility וכו' וכו', ופה אני יכול לעשות sign in commit לאשר את זה. אגב, ה-technical deals, אתם רואים פה למחורי זה, יש לנו פה resource של service request, שהוא יכול להכניס ולהפעיל. יש לנו פה גם results explained וכולי. אגב, כל ה-results explained האלה יכולים להגיע ישירות לבן אדם. זאת אומרת, אם אני עכשיו, הגברת את'ל הזאת, ואגב, זה לא השם שלי, אבל נניח, טני זה קיצור של משהו אחר, למרות שלך תדעו לה, זה גם יכול להיות קיצור של את'ל, זה שם קצת מוזר. אז בכל מקרה, אז יש לנו פה את את'ל, ואת'ל יכולה לראות בעצמה פה את כל התוצאות בפורטל שלה, או במקרה הזה בטלפון שלה. גם זה ממש חלק מהפתרון שאתם רואים כאן. אז זה דוגמה לחלק מהיכולות שקיימים פה. אבל מה שעוד יותר יפה, בפתרון הזה, שהוא מאפשר לכם ממש לבנות agents משלכם ולחוות את הדבר הזה. בואו נעשה את זה רגע רק שתקבלו איזושהי תחושה. אז נניח נעשה לנו פה איזשהו משהו שבודק משהו שקשור לכליות, לבריאות הכליות. אז נעשה את האג'נט הזה, אז יש לנו פה איזשהו אג'נט, והוא יכול לעשות כל מיני דברים. למשל פה, אתם רואים read the FHIR record, אז הוא ירצה להביא 3 סוגים של ריסורסים, במקרה הזה, אני יכול לעשות טסט סטפ, והוא הולך ומביא, אתם רואים, הוא מביא פיישנט אחד, ו6 קונדישנס, ואומרים לנו פה סיכום של מה יש לנו פה ב6 קונדישנס האלה, ו3 מדיקיישן ריקווסט עם הדבר הזה. זה חיפוש אחד, זה FHIR request פשוטים. אגב, יש לנו פה גם את חיפוש הסמנטי, מתקשר למה שאמרתי לכם פעם שעברה לגבי ה-vector search, אני יכול לבדוק גם את זה. פה אגב כבר יש לנו פה איזושהי תחושה למשהו לא טוב שקורה לנו פה. וגם פה אני יכול לגשת ל-AI, לראות ממש את הפרומפט שהוא ישלח, הנה, you are clinical pharmacist וכו' וכו', זה האבידנס שיש לי, מה אתה אומר לי על הדבר הזה? והוא ממש יכול לעזור לי להבין מה קורה פה, ואם אני אעשה נניח run על האג'נט הזה, אז אני יכול לראות למשל ממש מה קורה פה, והפעולות שהוא עשו, והנה, יש לנו פה איזושהי בעיה, יש לנו פה תרופה אחת שהוא מקבל, שבעייתית עם המצב שלו, ויש לנו פה גם הצעה לטאסק וכו'. אז יש פה דוגמה מאוד מאוד מפורטת, מאוד מאוד גבוהה, שמאפשרה לנו להבין מה זה אייג'נטים, איך הם עושים אינטראקציה עם ה-FHIR, איך הם אפילו מנצלים, אגב, עוד יכולות של איריס, זאת אומרת, יש לנו פה ממש אורקסטרציה של אייג'נטים שיכולים לקרוא ל-FHIR, לקרוא ל-LLM, לקרוא ל-Vector Search, הרבה מאוד יכולות עוד מעבר שאפשר לעשות את הדברים האלה. אז לפה אנחנו הולכים, ופה אתם יכולים לצפות, ליהנות ולהפיק תועלת מהדברים שאנחנו משקיעים בהם. עד כאן.
זה היה חיתוך חד כזה. טוב, נעבור לשאלות. If you have questions to Carl, Yochai, or Tani.
Okay, so I'll ask the first question to Carl. I want to circle back to the cancer example that you showed. Cancer is, in clinical terms, it's kind of a vague term, and in fact, it would translate to tens, maybe hundreds of condition codes, and potentially even into text written down in the clinical record and not coded even. So when clinician asks about cancer, you mentioned translation layer that is not LLM based from the model input into FHIR. So how do you handle this transition from a rather generic term like cancer into specific codes and into information that is not even perhaps coded in the clinical record?
Great question. Thank you for it. Yeah, so medical terminology, SNOMED, LONIC, ICD, and Hebrew display names are definitely things that we worked with, but with Mary, we do pull in LONIC codes, SNOMED, ICD, 10 codes. And so that's another way that if the clinician is asking Mary within those terminology and outside of just asking about cancer specifically, Mary can interpret that if it's in the medical record and then present that and present what's currently in the chart. But, you know, again, as I mentioned in slide 13, I believe that, you know, we are still that, you know, we are saying that binding across the Israeli national code sets is unfinished work, and that, you know, we're still working on that. But here in the States, definitely ICD-10 codes, SNOMED, LONIC codes, if it's in the medical record, if it's in the chart, the clinician can ask those simple queries to Mary, and Mary can interpret those.
Thank you.
Thank you for the question.
So any other question? If not, I think we can we'll end the webinar here. And I want to thank you very much for a very interesting webinar, and wish you all a good day, the rest of the day.
Thank you.
Thank you very much.
Thank you all.
Bye-bye.
Thank you so much.
Bye bye.